Okie dokie. Today, your objective is the students will learn the definitions of theoretical and empirical probability in order to compute theoretical and empirical probability. So, normally I do this in one day with what we would do after the quiz, but I've kind of separated it so you can really focus on the simple probability today. And then next class after the quiz, we will do a little more difficult probability. So, well, what that means is if you can get today's work done, I would highly suggest you catch up on anything you haven't gotten done yet. So I would check Edline to see what you haven't turned in yet or if there's anything you can do better. Okay? So the first thing we need to decide is do a quick review of basic probability. So you're going to see words like sample space, event, and theoretical probability. Sample space is the set of all possible outcomes, denoted by S. What that means is if you have a deck of cards, you have, picking an ace, a king, a queen, anything with cards. If you have a dice, your sample space would be rolling a 1, 2, 3, 4, 5, or 6, because that's everything that could happen if you rolled the dice. The event is going to be the subset of the sample space. So I'm going to be asking you for the probability of an event. And then theoretical probability is if an event has equally likely outcomes, which means you have a regular dice, you don't have a stacked deck, everything's pretty normal, and then sample space has equally likely outcomes. So I'm sure you can do this kind of without this fancy-dancy formula, but if you're interested, that's where the math comes from. Okay? So if you're looking at a six-sided dice, the sample space, so anything that could happen, equally likely, it's not a weighted dice, the sample space is your outcomes that you could have. So you could have rolling a 1, 2, 3, 4, 5, or 6. So that's 6 total outcomes you could have. So the probability of rolling a 3, you might see this written like this, probability of a 3. Well, there's only one time you could roll a 3, so 1 over 6. So then the probability of rolling an even number, so 2, 4, or 6. You see that's 3 over 6, but what can you do with that? That's right, you can simplify. Please simplify when you can. All right, a number less than 5. How many numbers are less than 5? So 1, 2, 3, 4. 4 out of 6. Make sure you simplify to that to 2/3. Okay? Number less than 10. Well, all of the numbers are less than 10. So you have a 100% chance of rolling a number less than 10. So that simplifies to 1. And then a number greater than 6. There are no numbers greater than 6, so you have a 0 chance of rolling a number greater than 6. So if you have any questions on that, please let me know. This is very basic probability, so I'm hoping you don't, but you never know. All right, now the cards, I will always tell you how many are in a deck, so if you don't know, please ask. Some of you might know cards a lot better than others. But in a standard deck, there's 52 cards. There's going to be, and I'll put these in red, 13 hearts, which are red, obviously, and 13 diamonds. So hopefully you realize that you have 26 red cards. And then you have 13 spades, which are black, and 13 clubs or clovers, whatever you like to call them. So you have 26 red and 26 black. let's see, you have 12 face cards, that might come up. So a face card is a jack, a king, a queen. We're not going to include aces, so I'll put a K for king, Q for queen, and a J for jack. There's 4 of each number. So there's 4 kings, 4 queens, 4 jacks, 4 aces, 4 2s, 4 3s, and so on. And that might be your only questions. Again, Belle, if you have a question, please ask. So the probability of rolling a king, so there's 4 kings in the deck, so that would be a 4 out of 52, or not rolling, picking a king, 4 out of 52, which you would then simplify to 1 out of 13. Okay? The probability of a heart, so hopefully you wrote that down. There's 13 hearts, so that would be 13 chances out of 52, which you should simplify to 1/4. Okay? And now you have to draw the king of hearts. So there's only 1 king of heart, which means you only have 1 chance out of 52 to get it. Remember, when in doubt, if you don't know how many are in a set or how many they're asking for, I will let you know. You don't have to have the number of cards and number of each set memorized. Alright, so that was theoretical probability. I'm pretty positive you should hopefully have a good hold on that. Empirical probability is, it applies to situations. Oh gosh, you can't read that. Applies to situations in which we observe how frequently, so how much something happens, an event occurs. So you're going to be seeing a lot of charts, and you're just going to have to kind of interpret the chart. So empirical probability is the number of times an event occurs over the total number of occurrences. So what I'm going to do is I'm going to highlight this box on your table is going to be the most important. So what you want to do is you want to add down, because the table is showing marital status of 212.5 million Americans 18 and over. So number of males and females never married. Miss Bailey falls into that category as of right now, though. Married, so you would add downward. Widowed, which means one of their spouses died. And divorced. Okay? So once you get those numbers, then you want to add across so you can find out the total number of males surveyed was 102.4 million. And the total number of females surveyed was 110. And that number should add up to the 212. And I've highlighted that because that's going to be our denominator each time, because that's the total number of people. Okay, so now we want to see one person is randomly selected from the population, find the probability, and this one's saying to the nearest hundredth, so we don't want a fraction. So it's 2 decimals, that the person is a male. So you would take the total number of males and you would put it over the total number of people. Hence why I highlighted that box. And if you simplify that, and remember this one wants to the nearest hundredth, female, or should go to 0.48. Okay? Now it wants to know how many is female. So you take the total number of females and divide that over the total number of people. And hopefully you can see that, hey, 48 hundredths plus 52 hundredths equals 1, because you're either a male or a female. So the males and females must make up the whole population. Alright, then you want to see if it's divorced. So it doesn't say it has to be a male divorced, doesn't have to say it's a female divorced, they just have to be divorced. So you pick the total number of people divorced, because it doesn't specify whether you're a male or a female, and you put it over 212 and a half, and we get, which means 10% of the people surveyed were divorced. Okay? And now never been married. So again, this does not specify whether they're male or female. So you would just take the total number of never been married, which I believe was 51 and 9/10, over the total number of people surveyed, 212 and a half, and you get about 0.24, which means 24% of people have never been married. Okay? All right, moving on to this next one. So the table below shows the number of people in the U.S. living alone in the United States. Your book has some very weird tables, so some of these are kind of weird. Again, this is the number that you're going to pay attention to. It's typically always on the bottom right. So again, it divides by males and females, and this time it divides by ages. So they've already calculated the total ages for you. So you just need to calculate the total number of males. So add across, you should get 12 and a half. And then the number of females was 16.8. Remember, this is in millions. And so our total number of people surveyed was 29 and 3/10 million. All right, so again, this wants, it has a decimal rounded to the nearest hundredth, so 2 spots. Okay, so the first one, we want to know the probability of being a male. So you would take the total number of males divided by the total number of people surveyed. So I will be around to check. Please make sure you actually do this calculation. I'm going to be around to check the number that you get. Then it's what the number of 25 to 34 age range. Doesn't specify male or female, so it's just the total. So sorry, I didn't give you enough space here. Okay, so I'll be checking that number. And then it wants the total number of females, so 16 and 8/10 divided by, so please make sure you round that correctly. And now here we're very specific. They have to be a woman and they have to be in the 15 to 24 age range. So, woman, 15 to 24 age range, that's 0.8, 8/10 divided by the total. So you're always dividing by the total. And I will check your answer for that. Okay? So after this, you hopefully you got the notes. I'll be around to answer questions, clarify, whatever you need. There's a classwork assignment, so I'm going to put the time you hopefully can get that turned in by, and then I'll also put the time we're going to do closure. So please remember, you also have a quiz next class.